Good morning and welcome to ICP Day 4. Let's do a little exercise. Think back to these early scientific drawings and to the scientific literacy of the many generations preceding ours. Now think about the kind of coverage we get in science today, in the media, in radio, in the exhibitions you see in museums, such as the Utrecht University Museum. This is where visitors of all ages have access to exhibitions ranging from human evolution to particle accelerators. We've really come a long way when it comes to educating the public in science. Now I'd like you to ask yourself, what can outreach do for you?
Esme Geerke. I'm a PhD student at the NIOS at Texel in the Netherlands. I was filmed for the NESC program called Tipping Point Ahead. It's an outreach program for high school students. I think it's a very important part of my job to communicate science. Personally, I always really enjoy if high school students come to the NIOS. I love giving them tours. If you do your best, you can really spark their fascination for what we're doing. It gives an extra stage to tell about your research. What I really enjoyed during making this video clip is that it puts you back at this childish fascination for the Earth system, whereas when you're at the point of your PhD, you're looking ahead at all this knowledge that you don't know yet. It can make you a bit insecure. But now, in explaining them, I realized how much I already learned at this point. So that's very inspiring to continue my scientific career.
Ahoy!
Hi, my name is Camille Lee and I'm at the University of Bergen in Norway. My talk is going to be about how the climate system communicates information from the North Atlantic to the subpolar regions and then all the way up to the Arctic, as well as back again. So this is very important for a number of paleoclimate applications, including understanding how the climate system moves heat up to the Arctic in low gradient, warm climates. And it's also interesting for understanding how signals to the Arctic, like meltwater pulses from ice sheets, might get back down and affect the rest of the climate system. So I'll be using a number of different types of modeling experiments, from fully coupled, state-of-the-art climate models, all the way down to quite simplified process models to understand this question.
My name is Jacques Lascar. I am an astronomer at Paris Observatory in France. I've been working for 30 years about improving the computation of the motion of the Earth perturbed by the other planets. And this is what my lecture will be about, because as the Earth is moving, the Earth's orbit is changing, there is a change of insolation on Earth, and this is the essence of Milankovitch cycle. So what I will show here is the backstage of this computation. I will show what is needed to get an accurate solution for the motion of the Earth, and also the fantastic interplay between geological data and astronomical computation.